dun 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 dun. Let's do some probabilities for averages. Here we've got a Coke machine. I kind of made these numbers up. Please do not contact the Coca-Cola company. Let's say it fills soda cans with 12 ounces, because that's what a can is supposed to have. But you can't say that it always has exactly 12 ounces to the nearest drop. There's a little bit of randomness that goes on, and I'll bet it's small. So the distribution we're going to say is normal. Here's our mean of 12, which is what we expect, and then 0.0001. Wow, that looks impressive. Which you would expect a company that's mass producing large amounts of something. They've got a machine that has very little variability. Our question is, what's the probability that a random sample of 80 cans will average 12.00284 ounces? Your first step is going to be you want to draw a picture. But we're going to ask ourselves, can I draw a normal distribution? Well, yes, it says it's normal. But even if it didn't say it's normal, you've got more than 30. You're double covered. So absolutely, we can draw a normal distribution. Your normal distribution will look something like this. Watch me pull a Samantha and put it magically on the board. So we have an average of 12. Now, what number goes right there? That's the tricky part. Remember, we're not talking about individual cans. We're talking about an average from 80 cans. So the number right here needs to be the standard deviation divided by the square root of n. What's our standard deviation? Don't fall for this trick. This is not the standard deviation. Did you notice there's no squared here? Mean nasty trick, right? You need to take the square root of that, which is 0.01, and divide that by the square root of n, which is 80, and I get 0.001118. Now, if you were really good at math, you could tell me where is 12.00284 going to land on here, but I don't want to do that in my head. So let's just find our z-score, and that'll tell us where it lands. Our z-score is going to be 2.54. So now I can eyeball. From here I go up 1 standard error, 2 standard errors, and half a standard error more. That's where 12.00284 lands. Now the next part is tricky. If I want the probability of this value, notice it didn't say this value or less, this value or more, it just said this value. How much area are you going to have on that one line? Answer, 0. This is an easy question. In fact, you might have seen that from the very beginning, and you didn't need to do all this work. But let's change the question to make it more interesting. Now we're doing the probability of this value or more. So there is my area. Tiny, small little area. How big is it? I'm going to put my z-score as 2.54, and I want the other side. I get 0.0055. Let's change this question one more time and make it even more tricky, like this. The difference is, before we were saying 12.00284 or more, and now we're just saying only the more than part. How does that change our picture? Well, in math, they would say draw a dashed line instead of a full line. But what happens to the area? Nothing. It's the same area. These questions are as easy as the last chapter once you get used to working with the square root of n. Ugh. Knowing that I'm recording makes my nose itch.